Hello everybody, and welcome to another video by Teeth of the Lamb. And my name is Steve Matthews, and you can find me on YouTube under Teeth of the Lamb. Today is Friday, June 21st of 2019, and the topic of today's video will be the craters of the moon, and specifically the shadows that are cast on the craters and the phases of the moon. I think by analyzing the craters on the moon and the how the light shines on them, that we can answer the question whether or not the moon is indeed rotating, or is it just a optical illusion of perspective, which I don't believe it is. For any conscious, reasonable thinking person, I think that today I can demonstrate beyond any reasonable doubt that the moon indeed does rotate, and it's not an optical illusion of any sort. Most of the data that I'm going to present to you today will come from two separate photographs taken an hour and 42 minutes apart, and I believe it was on the 14th, just a couple days before the full moon. Just to clarify, when I talk about rotation of the moon, I'm talking about the rotation of the face of the moon as it takes its circuit across the sky. It will rotate in a clockwise direction. So I'm going to go over a couple of real basic concepts on how light works and how it shines across the craters, and how you can determine which is the angle of light shining on that crater. Also, I'd like to the best of my ability, establish the direction of light coming from the sun and the angle. After that, I'm going to use the two photographs that I took that were separated by an hour and 42 minutes on the same day, and we'll be going over each crater individually to see what the angle of light is and how it's changed dramatically within that 1 hour and 42 minutes. And I think we can determine from that the moon indeed has rotated. Now, this is going to be fairly extensive and fairly exhaustive on a lot of these craters because I don't want to miss anything. And some of them I may have gotten right, some of them I may not, because you really can't tell on some of them. But you can by observing the minute, subtle changes in shadow. You need to have a keen eye because some of the color values in the shadows are only a couple of degrees different. And so you really have to pay attention to see where the shadows really are, because the moon is very luminescent. We'll be making a comparison of this photograph that was taken on 6/14/2019 at 21:03 hours. And this is about, well, on the 16th with the full moon, just to give you an idea. And here is the second photograph. It's separated by 1 hour and 42 minutes. And the moon did indeed rotate, and I'm going to demonstrate that also here, so you can see how far it moved. You can see here's the first photograph. It's 21:03, and I'm going to overlay the 1 hour and 42 minutes later. And you can see with the two arrows there the difference in how far it's moved. Now, with the numbers that we're given, which are a bunch of garbage, that would equate to about 400 miles, and that graph 100 miles per slice of the pie on that. So anyway, I'll include that, but I don't believe it. This is the difference between the two when you snap it back and forth. You can see it actually if I had done it longer, that moon will rotate sometimes uh, uh, almost a half a turn. This airplane happened to fly by when I was making that video, or taking those pictures, and this looks like a UPS jet, but with it I can determine the angle of the sun because it's shining on that airplane. I think it's a reasonable observation. So we can get kind of an idea of which direction the sun is shining from. And then you can see over here, there's the moon that I was recording. So I'll zoom in on that plane and make a good assessment to the angle of the light. And I think that's about right, and that kind of matches what we see on the moon. Not all craters on the moon aren't lining up to the sun. Some of them do. This is the ceiling in my doctor's office, and you can see on the upper portion how the light shines on the craters. The light is going from bottom to top here, and it gets washed out. You see how it's getting washed out on the top, and then you have a shadow on the bottom. Well, that's the direction of light, and that's how we can tell when we look at the moon. This works the same way. I'd like to show you real quick the photo on the 16th of the full moon. This thing was so bright, there was not hardly even one crater that could be distinguished. It was so luminescent, no shadows whatsoever, not even on the edges. And if it's a sphere, you would see some shadow somewhere. But this thing it lit up like it lit up right from under the surface. You can see those craters are just bursting out with light. And I don't think that's all coming from the sun. But you can see the brightest spots are in pink here. This is an infrared shot that I took. You can see that this full moon is completely void of crater shadows. There are none. That's why I had to fall back a couple of days before the full moon to make my analysis. Something that some of you may not be aware of, that when the moon rotates clockwise during its phases, it moves and carries the phased shadow along with it as one unit. The moon does not move independently of the phased shadow, and that's fairly significant. So I'm going to demonstrate that in a little simple graphic here. The moon does not move like this, as one would expect if you were getting had a fixed light source shining on it. The moon, you would expect it to move independently and the shadow would stay fixed. But that's not what we have. I mean, that's not what happens. When it does the phase rotation, it doesn't do this at all. The whole shadow goes with the moon simultaneously as one unit. And I find that a little bit odd. But when we get into watching the craters, we get something a lot different than that, which is very significant. So here, I'll let this go down one more time. This is what we should get. We should have a shadow that stays fixed, and we should have a moon that rotates within that shadow. But what we get is this. We get the shadow and the moon, and the Sea of Christ is the big round crater right in the middle. That's almost always smack dab in the center when it's phased on the right, from the light coming from the right. So this is what we get. We get a shadow moving, and remember, the sun's supposed to be stationary and fixed, and this will move completely in the daytime stuff, so it doesn't match the sun whatsoever. Sometimes it'll look like it matches the angle of the sun. Other times it doesn't at all. So I don't think it's coming from the sun. We're going to look at the craters in just a moment here. This is what we get. We get craters that rotate as the face of the moon rotates. We get shadows coming at different angles in on those craters. But the phase shadow moves in unison with the moon. But these craters on the surface, if they are craters, you will see shadows moving independently as the moon rotates, which is a big deal. That means that the moon is indeed rotating, because we're getting light shining on those, probably a lot of it coming from the sun. But I think a lot of the shadows, because they're going all different directions, I think some of them are not being produced by the sun. Now we're going to make our comparison of the craters that were 2 photos spaced apart by an hour and 42 minutes. You can see the angles of these shadows on these craters. The top one is the earliest one, and the bottom one is the latest one. But as the moon rotated, the face of the moon, the angle of the shadows actually changed. And I've looked at this before, and I thought, well, a lot of them kind of look at the same angle as the sun. And remember, we've determined on that airplane that it's coming in from the right at about a 45-degree angle toward the bottom. So that's the direction of the angle of the sun. And a lot of these look really, really close. They look like, well, yeah, they're coming from the sun. But you're going to see as we look through these that a lot of them look like they're not. And that's probably because there's another light source, and it's not all coming from the sun. Well, these match up. See the bottom one, how it's angled, and then look at the top one, how it's angled on either of those red lines. And if you really study that, you need to be really paying attention. But you can see there's quite a shift in the angle as the face of the moon rotated. And remember, it only rotated a small amount. The more you rotate it, the worse this would be. But this is the comparison between the two. You can see the angles there. And look at these 2 craters here, down at the bottom, and then I'm going to circle them on the top. Look how much different those are. This top one here, this is the earlier photograph, and this is an hour and 42 minutes later. You see how those shadows have changed? You have to really watch, have a keen eye, and I know a lot of people do. So you can see the difference. Look at these 3. Look how the angle has changed on those of the shadow in those craters in the highlight. Totally different. And the only thing that's moved is the moon, the face of the moon. We can see that in between the 2 pictures. You can see there's a comparison back and forth between those 2. But you can see that moon rotated. And these craters absolutely prove that it did, because the shadows in the craters also moved. And that's very telling. And it's a big problem for the globies. And do I think that I'm the only one in history who's ever seen this? Absolutely not. I think that every astronomical observatory on this planet, or on this world, I think every one of them knows the truth. And the question that rises is, why aren't they telling us? Because it doesn't take a genius to figure out the moon has rotated. That means that the whole heliocentric model is a big lie. Look at these craters in the blue circle on the right, in the center there. Look how much the angle has changed on those. Now look at the bottom red arrow there. And we'll go pan down and look at the other one. See the angle change? It's quite a bit of difference. So we're going to go through a number of these to make sure that we're seeing it right. Now remember, the moon is the only thing that possibly moved. The sun is fixed, and according to the heliocentric model, the moon has only moved about generously 1 degree in the sky in an hour and a half. Not enough to account for this. They say you have a fixed stationary sun, and the Earth moves, but it doesn't move very much in an hour and a half. Not this much, but the face of the moon did, and we have that photographs of that as proof. But look at those angles. Look at this crater here in the center that I just circled on the top, and I'll circle it here on the bottom. Now look at the way that's changed. Completely different shadow. I think every observatory on the face of this Earth knows this. I think that they're not interested. They're not looking at the moon, they're not looking at the stars, and they care less about it. What they're looking at is that they know their undoing is coming from above, and they're watching to see when it comes. And I think they're afraid. But that's just my personal opinion. These craters aren't opinion. They're fact. This is what I see, and I'm showing it to you. And you can do this by taking 2 photographs almost any time that you can see with a reasonably good camera. I used the Nikon P1000 for this, and you can see these differences yourself anytime. Excuse me. I'm recovering from either allergies or plague. Everybody in this area had a bad cough. So we're going to do some more here in just a minute. This gets a little bit long, but it's worth it because you need to see some of these other craters, how they've changed. Some of them are real subtle, and you really have to pay attention. But others are very, very prominent and distinct. Look at this little crater on the bottom. I just circled in the center in red. And look at the shadow on the top there. That's completely different. And this is all within an hour and a half. And look at that one. It's different too if you really analyze it. You got to have a good eye to see those differences. Some of them real close. Look at that one, the third one there that I just did. There's a divot on the top and there's not on the bottom. Look at the one over there on the right. That's different too. It's longer. Yeah, look at this one over here on the right. You can see that's a different shape. On the bottom, it's rounded on the end. This one, you can see the shadow there. Look at that crater there where the arrow is. I'll start adding some arrows, otherwise it gets confusing. Yep, you can definitely see a difference in those. These are a little harder to tell, but if you look at this one and that one on the top, that's shorter on the top and it's longer on the bottom, the shadow. Look at this little crater. That's completely different. These may not be craters. And I think they're indentations, yes, but it's the surface of the moon, how it's made. I'm going to go through enough of these to show you beyond a reasonable doubt that it's definitely rotated and it's definitely got a different angle of light coming at it. Look at these here. Completely different angle. And that one's different too. Look at the angle of that one. Wait until we get into the bright portion of the moon. You're going to see something really interesting. I don't think they're all coming from the sun. That one where the arrow is, the top one is, you can't even see a defined shadow. On the bottom you see a defined shadow and it's longer. Yeah, look at this crater. And I'm going to circle it here. Look how long it is on the bottom and how deep it is, and on the top it's not nearly as pronounced. And the little one right beside it on top, that's almost invisible, but now it's changed its angle and it's real dark. Now this one is real long on the bottom and it's almost real short shadow on the top. So we've definitely got the light has changed angle. And where did that come from? The moon rotated. Because in the numbers and model that we're given, the sun is fixed and the moon moves about 1 degree in the sky, and the earth has moved very little in an hour and a half. This is all caused by the rotation of the moon, the rotation of the face of the moon. And remember those phases, the phase side of the moon, it moves right along with the moon. It's not dependent on a light source that I can tell. But these tell you that it really did rotate. Now I know some of you may not be religious and some may, but Enoch talks about look at these three. The one on the left is 3 days before, right here. And see how pronounced those craters are? Then they get more faint, and then you get the full moon. You don't have a shadow one on the edges at all. And on the outer edges of a sphere, you couldn't hide shadows. They would be more pronounced in a real bright sun. But anyway, back to our craters here. So I was going to say that Enoch says that a portion of the moon's light comes from the sun, and the rest of it produces on its own. Some of these almost look, when you're coming from these craters, look like beams of light coming off of the surface, and they look like they're luminescent inside, and the light is coming from within the moon. Just an observation. I don't have any proof of that, except that we've got angles going all over the place when you start looking at these craters individually, and they're not all coming at a 45-degree angle from the right-hand side. Look how bright some of those spots are. Remember our model here? When we're looking at those craters, the lighted side is darker, and the highlighted side is away from the light source. The light here was coming from the bottom up, and look at the top, is it very indistinct and bright, and we got a shadow toward the bottom. This is just plaster on the ceiling, so you know how that is, got indentations and ridges. Now look at the highlighted side here. This, I think, is going completely opposite. So I think the moon is generating some of its own light and casting some highlights and stuff on these craters. Look how bright that is. All those bright lights on it all over. I don't think they're all reflections. And off to the on the edge, very few shadows whatsoever. You can see the shadows, they're very faint. And then you see the highlight on that, and that's the right direction. To me, it looks like some of these craters are bursting forth with light right from within the moon. Look how bright they are. It doesn't look like it's coming from the sun at all. Like I said, this whole surface of the full moon, a couple days after this, was so bright you couldn't make out any distinct shadows at all, and just had a lot of bright lights like what we're seeing here. I think some of the craters on the moon might be getting its light from the sun. I mean, as far as the angle and stuff, but all of this here, I don't think that's caused by the sun at all. They're way, way too bright. That big crater looks like light is actually emanating from it. Looks like beams of light. And you see like a webbing on the surface of the moon. It looks like beams of light also. Look at these, they're going completely opposite direction. The highlight is on the opposite side of the direction of the light. And they're just light going all different directions when you get into this highlighted area. And then you get into the shadowed area, and then they look more like they might be coming from the sun. But even those start going all different angles. Right up here on the upper left-hand corner of the moon, they look like about the 45-degree angle that we saw on the airplane. And then, so that's about the right angle from the sun. But when you get down to the bottom, they're headed almost straight down. And now where's that light coming from? And there's some real puzzles there. There's a lot of things we don't know about the moon, and a lot of things we probably never will know about the moon. But I don't think the truth is something that we're not going to know. I think that these craters show that the face of the moon has indeed rotated, and even though it was only an hour and a half, it shows a very pronounced difference in those craters. In the shadows. So I'd say yes, it's definitely rotated. Look at these. Some of them are just bursting with light all the way around them, like they're beaming. You see the rays of light shining out of them? It's just illuminated the entire surface, and that's not reflection either. You would always have sharp shadows coming in, no matter what. Remember the angle of this 45-degree angle across this surface, and around the curve, that you're getting shadows, and on the surface you're not. No, that just a lot of stuff there doesn't make sense to me at all. But some of them, enough of them, are coming from the sun, so you can see that when the moon's face rotates, that it's indeed rotating. But the phased shadow side of the moon moves along with the moon, and that it shouldn't do. That means that the phases are not being caused by the sun. And I know that because many times when the moon rotates, that phase could never be cast by the sun. I can see it in the sky. The angle is completely off. So yeah. But yeah, some of these other craters might be getting light from the sun. It doesn't matter anyway, because the heliocentrists, they have no other light source, and it doesn't move, and those craters, the shadows in those craters are moving, so the moon's moving. It's rotating clockwise in the sky, just like what we see. Anyway, this is about done here, and I just wanted to be real thorough on it for you.